Hello everyone, this is example number 3, and from example number 2 we had the data set, and now we will be plotting the slope. So a lot of the students uh, do not know how to uh, take the triangular part from where we calculate the slope of a given graph, and we will be plotting slope for a simple linear curve. And in the next lecture we will discuss how we can plot uh, or draw a fine slope for a curve which is not linear. So for a straight line graph, it is very simple, very simple how to find a slope. You just take any point on this line, the line you have drawn by connecting all the points on the graph, the line of best fit, any line that fits. For example, if your data lies like this, so points are not exactly on the line, but they are somewhere near the line. So you just draw a line that crosses at least three of the points or is very near to the points. Well, for the given data set, we already had the line drawn. So how to find the slope of the graph? Slope is an important quantity in physics, mathematics, etc. And it gives you the idea of certain physical quantities, like the slope of the speed and time graph gives you the acceleration at a given point. So for a straight line graph, the acceleration is constant. So acceleration for a straight line graph will be change in speed upon change in time. We have to see the change. We can take change from any point on the graph. So how to find this change in speed and change in time? So we take any 2 points on the graph. Usually what we do, we try to find points on the graph which passes through this line, the blue line we have just drawn. So the point must pass from this line, and it should pass from the intersection of these lines 1 2 3 4 5 6 7 8 9 10, and similarly 1 2 3 4 5 6 7 8 9 10. So where these grid lines cross, and somewhere on the graph paper our plot will also be passing through these lines. For example, if this is the point where our line is also intersecting the grid, so three lines are intersecting here. I don't know whether it might be intersecting here on an actual graph paper, since I'm just taking an example and I have shown you a magnifying part that how things should happen. So somewhere here, let's say here, all these intersections take place. So we write this point as x1 comma y1, and similarly say somewhere here on the graph we have another such kind of intersection. So we label this number x2 comma y2. And guys, do remember these 2 points, these green points that I have drawn, these points must lie on this blue line that I have drawn. So this is compulsory. So you can't do it like this, that somewhere near these x and y axis intersect, but this line does not. So you can't take that point as x1 and y1, and similarly not here as x2 and y2. Well, for simplicity, you can obviously take this point which has an intersection of x and y axis also, and the blue line also passes from here. Similarly, this point will also have the x and y axis intersection. This point also lies on the blue line. So you can also take these points. What I am trying to say is, um, you just need to find two coordinates, x1 y1, x2 y2. X1 y1, we are going to label x1 y1 here, and these points are 20 comma 15, and the other point, which is x2 comma y2, is 40 comma 23. So we use the formula to find the slope, y2 minus y1 upon x2 minus x1. So y2 is 23 and y1 is 15 and x2 is 40 and x1 is 20. So what we have? We have 23 minus 15 is 8 and 40 minus 20 is 20. So 20 upon 8. So it's like 2 4s are 8, 5 4s are 20, 2 upon 5. So what's 2 upon 5 is 0.4. So the slope of this straight line graph is 0.4. Okay. So now I'm going to tell you few mistakes that students do while plotting graphs. They take any 2 points that lie exactly on the line and they take them very close like these points, these 2 points, and they measure slope like this. This is change in x, which is delta t in our case, and this is change in y, which is delta s, and they use this kind of small triangles. Well, to be precise, it is a straight line graph, so we have a lot of accuracy here. Even if we take these close points, we will get exactly the same answer, but in many other cases we don't. So it is a good practice that you take 2 points that are very far away. That's what I have taken. I have taken 2 points which were very far away. The farthest point I have taken, and then I count the change delta t, and similarly here delta s. Okay, this is all for this example. Thank you and have a nice day.